Hello guys, today we're going over the 2009 Math Prize for Girls problem 12. So, Jenny places 100 pennies on the table, 30 showing heads and 70 showing tails. She chooses 40 of the pennies at random and turns them over. That is, if a chosen penny was shown heads, she turns it to show tails. If a chosen penny was shown tails, she turns it to show heads. At the end, what is the expected average number of pennies showing heads? Alright, so this problem is quite simple after you understand what is going on. So, firstly, there is a 40/100 chance for each penny to be turned over. So, we want to see the average amount showing heads. So, let's first calculate the amount of tails that will be flipped. So, there are 70 coins that are showing tails, and there's a 4/10 chance for each of them to be flipped into heads. So, our expected value is 28 coins that will be flipped to heads. Now, we don't want the heads to be flipped, so there's 60/100% chance to multiply by 30. And we don't want the heads to be flipped necessarily, so we don't want the 40 pennies at random to be chosen, any of them to be heads. So what we do here is we get 18 coins. So summing these up, our answer is 46 coins as our expected value. Hello guys, here on 2009 Math Prize for Girls problem 15. So let x be the cube root of 4/25. There's a unique value of y such as 0 is less than y is less than x, and x to the x is equal to y to the y. What is the value of y? So your answer in the form C, the c root of a over b, where a and b are relatively prime positive integers and c is a prime number. So what we can do is first we want to simplify this expression. So x is equal to 4/25 to the 1/3 power, as that is the definition of exponents, and we can simplify to 2/5 to the 2/3. We see that y has to be in the form 2/5 to the omega, otherwise there is no possible way of achieving that. And so now what we want to do is we plug it in, so we get 2/5 to the 2/5, the 2/3, times 2/5 to the 2/3. This is equal to 2/5 to the 5 omega times 2 to the 5 to the omega. And so what we want to do is that we want to equate the exponents as they are both in the power to the fifth. So 2 to the third, 2/3 times 2/5 to the 2/3 is equal to omega times 2/5 to the omegath power. And so we want to take log 10 here. So log 10. We get 2/3 plus, missing the exponent at the front. So you want to put like terms on both sides. And so what we get is that we get log 2/3 minus log w. This is just log 2/3w. And this is equal to w log 2/5 minus 2/3 log 2/5. And so this means that log 2/3w is equal to w minus 2/3 log 2/5. And so this means that 3w/2, we can take the reciprocal, and we get this is equal to 2/5 to the 2/3 minus w power. And so what we want to see is that w has an obvious solution, which is 2/3, as that will yield 1 on both sides. But the other obvious solution is that w has to have a power of 5 in it, otherwise it is impossible to have 5 in the denominator. And so we see that 5/3 is a valid outcome. And so what we get now is we get 2/3 and 5/3, and we want to see what is the unique value of y such that 0 is less than y is less than x. And obviously 5/3 is going to be our valid outcome, as x is 2/5, and the greater the power for numbers less than 1, the less the number. And so 5/3 is our answer. And so we want to find what y is. So 2 to the 5th to the 5/3 is equal to the cube root of 32 over 3125. Hello guys, today we're going over the 2009 Math Prize for Girls, problem 16. So let x be a real number such that the five numbers cosine 2 pi x, cosine 4 pi x, cosine 8 pi x, cosine 16 pi x, and cosine 32 pi x are all non-positive. What is the smallest possible positive value of x? Express your answer as a fraction in reduced form. So first of all, something we want to notice about cosine is that if we draw the unit circle, cosine is x, so this entire sector is what we want, as we want cosine to be negative. So this means that, for example, 2 pi x has to be greater than pi over 2 and less than 3 pi over 2, as this is pi over 2, this is 3 pi over 2. So this is the algebraic inequality interpretation of this. So now we can erase. So let's divide pi and multiply by 2 on both sides. So let's multiply by 2 over pi on both sides. We get 3 is greater than 4x is greater than 1. And so then 4x is in the inequality 1, 3. So then 8x must be in the inequality 2, 6. And so this still corresponds to 1, 3, as 2 is in the quantity 1, 3. So 16x corresponds to the inequality 4, 12. This can no longer fit in 1, 3. This has to fit in 5, 7. So this is more accurate. So 32x is 10, 14, as multiplying by that. And we see that all the periods have to be 1, 3, 5, 7, 9, 11, as seen in here, as seen in the unit circle. Let me just make a new page real quick just to have some more room. So this corresponds to 9, 11. And then 64x is 20, 28. And so let's list out our possible periods. And we see that 20 has to go to 21 because it's greater than 19. So this goes to the period 21, 23. And so the smallest possible value of x here, 64x here is 21. So if 64x is equal to 21, then x is equal to 21 over 64. Hello guys, today we're over the 2009 Math Prize for Girls problem 17. So let a, b, c, x, y, and z be real numbers such that they satisfy the three equations 13x plus by plus cz is equal to 0, ax plus 23y plus cz is equal to 0, ax plus by plus 42z is equal to 0. Suppose that a is not equal to 13, x is not equal to 0. What is the value of 13 over a minus 13 plus 23 over b minus 23 plus 42 over c minus 42? So first of all, we want to eliminate the equations that have nothing to do with what we want. And so what we can do is we can simplify this by turning this into 1 minus a over a minus 13 and the negative version of this. And so by symmetry, this is what we can do for all of the terms. And so what we get is negative 3 plus a over a minus 13 plus b over b minus 23 plus c over c minus 42. So what we can do now is that now we want to find what this is. And so how can we get a minus 13? We want to manipulate the equations given. So first let's take this equation and let's move it down. So you get 13x plus by plus cz is equal to 0. And so what we can do to solve this is that we can do 13 minus a, which gets us that a minus 13 term, plus ax plus by plus cz is equal to 0. And so moving this to the other side, we get x is equal to ax plus by plus cz all over a minus 13. And we multiply this by a to get that a over a minus 13 term. So now, similarly, we can do this for all of the other terms. Let me just make a new page. So now what we can do from here is that we have ax plus by. We add the three terms together. This is equal to ax plus by plus cz. We can factor it out of all the equations. Times a over a minus 13 plus b over b minus 23 plus c over c minus 42. And so now cross these out, this is equal to 1. And so our answer is just negative 3 plus 1 is equal to negative 2. Hello guys, today we're on the 2009 Mathematics of Girls problem 19. So let S be a set of 100 points in the plane. The distance between every pair of points in S is different, with the largest distance being 30. Let A be one of the points in S, let B be the point in S farthest from A, and let C be the point in S farthest from B. Let D be the distance between B and C rounded to the nearest integer. What is the smallest possible value of D? So let's say B is right here, and so that means that C is distance r away for example, and so that means that C can be any point on the circle with radius r centered at B. And so let's say there's another point A, and A is not the farthest point of B, so it can't be directly on the circle. Now let's say P is the closest point on the circle next to A. And so as A gets arbitrarily close to P, obviously B is the farthest from A, so it would be another circle with radius r, as PB is r, and in this case, every point in S has to be in this overlapping area, as every point in S is not as far from A as from B. And so this is our area right here, and so the two farthest points in this area are these 2 points. And since this is an equilateral triangle, we have this is 15, so this is 30 over root 3 as the radius. And so we want to find the smallest possible value of D. So 30 over root 3 is equal to 10 root 3, and root 3 is 1.71 rounded, so that's 17. Hello guys, today on the 2009 Mathematics Girls problem 20. So let y0 be chosen randomly from the set 0, 50. Let y1 be chosen randomly from the set 40, 60, 80. And let y2 be chosen randomly from the set 10, 40, 70, 80. And let y3 be chosen randomly from the set 10, 30, 40, 70, 90. In each choice, the possible outcomes are equally likely to occur. And let p be the unique polynomial of degree less than or equal to 3, such that p of 0 is y0, p of 1 is y1, p2 is y2, p3 is y3. What is the expected value of p4? What we want to do is we want to find the expected values for y0, y1, y2, and y3. So then we can find the expected value of p, and then we can find the expected value of p4. So first of all, the expected value of y0 is going to be 25, as there are 2 choices, and 50 over 2 is 25. y1, the expected value is going to be 60. y2, the expected value is going to be 50. And y3, the expected value is going to be 48. And so now what we want to do is we construct our polynomial, ax squared, ax cubed plus bx squared plus cx plus d. So d we already know is 25, as p of 0 is just 25. And then now we have a system of equations. We have that a plus b plus c is equal to 35. 8a plus 4b plus 2c is equal to 25. Then 27a plus 9b plus 3c is equal to 23. And so now we want to solve the system of equations. And so first we want to add these two together and subtract from this. And so what we get from adding the first two together is 9a plus 5b plus 3c is equal to 60. And so we subtract, and then we get 18a plus 4b is equal to negative 37. And so that is our first equation. So let's erase this. Okay, and so now our second equation, let's multiply this equation by 2 and subtract it from the second equation. And so what we get is 2a plus 2b plus 2c is equal to 70. We subtract it from the first equation. We get 6a plus 2b is equal to negative 45. So now we have these two equations, and now let's multiply this equation by 2, and then we get 12a plus 4b is equal to negative 90, and we want to subtract them from each other. So we get that 6a is equal to negative 37 plus 90, which is going to be 53. 53. And so that means that a is 53 over 6. And so now what we want to do is we want to plug in a is equal to 56 over a is equal to 53 over 6 into this equation. Then we get that 2b is equal to negative 49, negative 98. So that means that b is equal to negative 49. So this is great and all. So now let's plug both of these equations into the first one. We get that 53 over 6 minus, and 49 times 6 is 294, as it is just 30 times 6, it's just 50 times 6 minus 6. So 294 over 6, and then plus c is equal to 210 over 6, and so that gets us c is equal to, from here we get 241, so c is equal to 451 over 6. So now we want to find P4, so we do 64 times 53 over 6 plus minus 16 times 49 times 6 all over 6 plus 4 times 451 over 6 and plus 150 over 6. And so we want to find what this value is going to be. And so basically what we do is 64 times 53. I'm just going to use a calculator to speed up this process. But in the actual test, you would have to multiply this out. 3392, and then 16 times 49 times 6. That's going to be 4704. And then 451 is easy enough. That is just 1804. And then 150, as we've already calculated. And so using a calculator, we get that this sums to 642 over 6, and so our answer is going to be 107. Sorry. Thank you guys for watching. If you like this video, make sure to like and subscribe, and peace.